Okay, problem 3. For the accompanying data set, draw a scatter diagram, compute the correlation coefficient, and determine whether there's a linear relationship or not. So 3 parts to this problem. And so part 1 is a scatter diagram, which is a visual descriptive. You can see the possible scatter diagrams in part A. Compute the correlation coefficient. That's what we almost always call little r. So that's a numeric description. And then make an assessment of the significance. So this is a hypothesis test in disguise. We know that it's a hypothesis test, but if you are doing the sections of the book in order, it hasn't been covered yet. Okay, so let's figure out which one of these is the scatter plot. Click to see the data set. Let's open it up in StatCrunch. Okay, I'll move it over from my other screen. This is a graph. So to graph scatter plot, because we want to a scatter plot. X is the X, Y is the Y. So I'm going through a lot of these StatCrunch routines quicker than I did at the beginning of the course. I think that a lot of you who are using StatCrunch are getting used to how to input things into StatCrunch. Always some variables to be put in at the beginning. When you put enough in, you click compute, and here's the plot. So it looks like there are 2 points on top of each other. It looks like somebody lying down with their hand in the air. So it's not A, because A, the person it's going upwards. It's not B. I don't see this point down on the lower right. It could be C, but it's not D. So it could be C. If I compare this to C, there's a point here, 2 points and a point up, and then a point at the very bottom, which is here. So it looks like C. Correlation coefficient. Actually, let me just do this real quickly in Excel, because this is not hard in Excel either. Click, click, open in Excel. So in Excel, you can highlight the X and the Y and all the numbers, insert, charts, scatter. So insert a scatter plot. Usually you'll see more of these icons, but I'm in a low resolution mode. And here it is. You see it's the same picture. Kind of the person lying down with his hand up in the air. So drawing graphs like this is also quick in Excel. Next, calculate the correlation coefficient. So close this off. The correlation coefficient is one of the basic summary statistics. So summary stats correlation. Choose X and Y in any order. The correlation of X and Y is the same as the correlation of Y and X. Compute. Minus 0.496. Minus 0.496. Just copy the 3 decimals off of StatCrunch. So hopefully you're enjoying the use of StatCrunch or Excel. We're keeping this course we're keeping the amount of hand calculation down in this course so we could try to emphasize the interpretation a little bit more. So that's excellent. Is there a linear relation? Well, how many points were there? There were 5 points. So here's a long way of doing it. There are 5 points. So we click the critical values 0.878. So the picture for that means, remember the correlation coefficient is between -1 and +1. That means 0.878 and beyond is the rejection region. So positive 878 and higher, minus 878 and lower. Those are the rejects. Reject means significant relationship. So here, our correlation was around -0.5. So our correlation was here. It's in the do not reject region. Okay, so the correlation is negative, and the absolute value of the correlation, 496, is less than 878. What we're looking at is just the number part without the sign of the correlation coefficient. That's the absolute value. So the absolute value is 0.496, is less than or not greater than the critical value, which was 0.878. So no linear relation exists because it's a do not reject. Where do we find the 878? If you click the critical values table, 5 points, 0.878. Okay, so this is a two-tailed test. So let's talk about it in our hypothesis test terms. So this is number 3. We're doing a two-tailed test. The null hypothesis is that the correlation equals 0. In other words, no relation. X and Y have no relation. The alternative, this is a two-tailed test, is that the correlation is not 0. So there is a relation. According to this table, the critical value is 0.878. Because when I clicked on it, wrong one, we have 5 data values. N equals 5 means the critical value is 878. Yes, 5 total numbers used, 5 numbers on the scatter plot. See here, 28 is 1, 67, 66, 79, 95. There are 5 pairs of numbers. So there are 5 points on the scatter plot. Okay, that's exactly right, Rhonda. So in the classical method, I'll make this a little bit bigger. This is a two-tailed test, so everything from minus 878 to the left is a reject. So this means we believe H1. Everything from positive 878 to the right is a reject. So here's also where we believe H1. It's a two-tailed test. In our test statistic, the correlation coefficient is somewhere here in the middle. It's a do not reject. That means there's no significant relation. Basically, 5 points is not very much to show a pattern. Okay, correlation coefficient is negative. 0.496, which is the number part of the coefficient, is less than 0.878, no relation. Well, not that each H0 is necessarily correct, Kendra, but H0 is believable. It's believable that there is not a correlation coefficient. So instead of saying no relation, what would be more accurate is to say no significant linear relation. There might be a little one, but it's not detectable from the data that we have. Check our answer. Just show you one thing.